Hello and welcome back to the lecture on applied econometrics, and we have been talking about dummy variable. And in the previous lecture we explained what is an intercept dummy, and we have shown graphically the impact of the change in the value of the dummy variable. Okay, so what we have shown here, if someone is a male, so then that person's income is increasing by rupees 385.9 rupees every week vis-a-vis if a person is a female. Now, we have shown previously that how we really code the dummy variables. We have shown that usually we have 0 and 1 as a value of dummy variable. Okay, so it is for gender, it is for sector, and so forth. Now, what if instead of 0 and 1, I would have, like just because I want it, I could have marked it as like, 2 and 5, let's say, or 0 and 5, or 1 or 4, whatever I want. So what would have happened then? So let's actually try to do that. Let's say in the previous case I had gender is equal to 1 if sex is equal to 1. So that is male is I have assigned it as 1, whereas female we have assigned it as 0. Okay, so I'll just use the same codes, just that I will change the values here, and here I'm going to, so let's say, if someone is male, I'm going to write it as 5, and if someone is female, I'm going to write it as 3, let's say. Okay, so I will do the same regression equation, but I have changed the values here, the values of the dummy variables. So I'll just try to explain what will happen. So I'll run the full code here, and if I run it, I will see that the value has become this 192.9. Okay, so the previously we have seen the value was 385.9, and now it has become 192.96. Now what is happening here? Now you have to understand, so this is a good example that will give us a sense of how to interpret the effect of the dummy variable. So you have to understand one thing, that in the previous case, when I assigned male and female as 0 and 1, so my program was actually trying to explain the effect of the dummy variable, the effect of the dummy variable for 1 unit. So the moment you move from 0 to 1, you are moving 1 unit. So 1 unit change was giving me a value of 385.9. Okay. But now what I have done here is, you see that I have valued it as 5 and 3. So you remember that always in dummy variable we are actually measuring the relative impact, right? So here I am measuring the impact, so 5 is the male and 3 is female. So I am measuring the impact of male vis-a-vis female. So basically I am measuring the impact from 3 to 5. Okay, so I am measuring the impact of 2 units. So I have moved from 3 to 5. So essentially, I am representing the impact of 2 units. So I am saying the program that, okay, I have changed my dummy variable by 2 units. So what is the impact? So what the program has done, simply, it has actually, you remember, the coefficient means the impact per unit change. Okay, so impact per unit change. So it is saying that, okay, so here you have changed 2 units, but per unit change is 192.96. So which means that if you multiply that with 2, so which will actually give you the full length difference between male and female, that is going to be the, that is going to be 192.9 into 2 is basically the same value that we got, 385.9. So essentially all that is saying that it simply depends on how you choose to define the difference. Okay, so if the difference is of 2 unit, so then what you will do is you will take, like the way it interprets is it will give you the impact for 1 unit, and then to get the full unit you have to multiply by the the number of units you have sort of differentiated between these 2 categories. So essentially you will have to multiply here by 2. Now if I, instead of 5 and 3, let's say if I would have given a value of, let's say I'll write it again here, let's say 5 and 2. Okay, so that means now I have a difference of 3 between these 2 categories, and what I'll get is that I am going to get an even smaller value of the coefficient. So 1/3 of 385 we are going to get, because we have to multiply 3 to reach there. Okay. So if you go back, I will see that it is going to be 128.6. Now if you multiply 128.6 into 3, now the difference is 3 and per unit change is 125.6. So if you have to multiply by 3 to get the full difference between male and female. So if you do that, so 128.6, it is going to give you the value of 385.9 that we had in our in the first place. So doesn't matter how you define the values of the dummy variable, the interpretation remains same. So you have to just make sure that you are interpreting it correctly. But it is just for illustration purpose. Usually we always keep it as 0 and 1. Okay, so this is something just for our understanding. Now let us talk about something that we have seen previously. In the previous equation we have seen for the intercept term. Okay, for the intercept term, what we have seen is a negative value. So negative 882.4, and that too significant. So what does that mean? So it essentially means that if you have everything is equal to 0, all the explanatory variable is equal to 0, a person's income is going to be minus of 882.4 rupees. Now, how is that possible? So oftentimes what happens, previously we have seen, if your model is not correctly specified, or if the functional specification is not correct, so then what will happen is that you will get a sort of a constant term which is not really explainable. Okay, so it is basically, if you actually have a better model with all the different variables included, you are likely to get a constant term which is more sort of like, which would make more sense. So that's it. So at this moment our model is not really correctly specified, so that's why we see a constant term which may not have a very sort of good meaning. Now we have seen in the previous equation that we had if we go back to the diagram, we have seen that our equation for males and females, so they are essentially same. The only thing that differentiates a male's equation vis-a-vis a female's equation is this delta term. All right. So if I have got this value, let us actually go back to the regression equation. So if I take the full equation here, where we have used experience square and so forth. So here, if I have this full equation, so how I will write it down? I will write it down as this. Let me actually. So my wage is equal to 409 into education, general education, plus 105 into experience, plus we have minus of 0.96 into experience square, plus 177.4 into gender, 177.4 into gender, minus 386 into sector, 386 into sector, plus our constant term, which is minus of 2644. Minus of 2644. Okay. So this is my regression equation. Now all that we will have from this equation is that we actually have a regression equation for a male and a regression equation for a female. So in this case, my gender is equal to 1 means it is a regression equation for male. So essentially that would mean, if I put the value of gender is equal to 1, because that is a regression equation for male, so it is going to be 409 into gen edu plus 105 into experience minus 0.96 into experience square. Now, if I add this, so if I put the gender is equal to 1, it will mean that I have to add 177.4 and then I can subtract 386 sector and then of course a constant term which is 2644. So, note that here the coefficient for general education is same as this, same as the first equation. The other coefficients, experience square, all they are going to remain same. So, this is the equation for, let us say, male. And what will happen for females? What will happen for females is that the same thing, just that you will not include this part, okay. So, it is 409 general education plus 105 experience minus 0.96 experience square, and then you basically do not include this value here 177.4 because here your gender term is nothing but 0, okay. So, 0 into this value is going to be 0. So, you do not include that. And what you have here is, let us minimize a little bit, minus 386 into sector minus 2644, right. So, everything else remains the same. Only thing that is changing is that you are basically vanishing this value of the gender coefficient for females. So, there is no corresponding value here, there is no corresponding value here. So, only thing here that is changing is that for females, for males I have just added the delta term which is in this case 177.4, and whereas for females it is not there. So, for females the base equation, you do not include any value for the gender category, the dummy category, because it is a reference category, but for males you simply add the impact for gender because the way you have defined it, male is equal to 1. All right. So, that is how we sort of understand the regression equation. So, essentially the point remains, the crucial point that remains is that of course, we have explained this two regression line, but the crucial point that remains is that the slope for the two regression equation is same. So, the values here, the 409 for male is same as the value for 409 for female. Similarly, experience 105, 105 and 386, all other things are remaining same, remaining constant. So, and that is what is quite obvious because the slope of these two lines, they are essentially parallel lines. So, slope of these two lines are going to be same, right, because they are parallel. Now, what does that really mean? What that means is that it is as if the impact of education and experience square, so if it is a theta, it is a theta. So, it means that as if the impact of education and experience square, they are all basically same for males and females. But if we run a regression equation actually separately for males and females, will we get the same result? So, let us see that. Let us see that. Now, actually this is the equation, and what I am going to do is I am just going to copy, I do not want to write it again, and what I am going to see is I will simply instead of, so let's actually copy paste it here. So, I had this full equation. Now, I will not have the gender dummy here, I remove it. Instead, I will run the regression equation one it for male and another time it is for female. Okay, let us first actually let's actually run it first. Let me actually run a separate equation here, and here I remove gender. So, first I will run the full equation, then I will run one for male and one for female if gender is equal to 1, and here I will again copy this regression equation, and here I will have if gender is equal to 0. Okay. So that means 1 is for male and 0 is for female. All right. Actually, let me, before that, because I have previously assigned these values here, so Stata is reading gender is equal to 2 and 5 here. So let me actually change the value of gender first here. Let me run this. Now I will get the right sort of value of the coefficient, gender dummy coefficient. Now let's run it first. So I have run the equation as it is with gender as a dummy variable, okay. And if I actually see it, I have the regression equation here, and then if I should be fine. Now let's see. Now we'll see this. We got the regression equation here, one for male, one for female, and previously we had the regression equation for both the categories together with gender as a dummy variable, okay. So we had, first thing to note, we had this number of observation 4,490 for the full sample, and here we had 3,716 for males. So there are 3,716 males because I have specified gender is equal to 1. So this is a subsample regression where we had regression only for the male category and for females when gender is equal to 0. So I got a number of observations 774. So if I add this to 774 and 3716, we will actually end up to this number, which is 4,490. Now, what you have seen previously is that when we explained the intercept dummy, we explained that the slopes are going to be same, right? And if the slopes are going to be same, that means in the regression equation, we will have the value of the coefficients for other explanatory variable, they have to be same. Otherwise, the regression line, the slopes are not going to be same. So essentially, if that is true, my subpopulation regression, the subsample regression should actually provide the coefficient for general education as 409, experience should come as 105, and experience square should come as minus 0.55. Okay, so let's see if we are actually getting that. And you see we are getting here 424.5, experience is 104.3, and experience square has become minus of 0.9. Now this is for the one regression, that's for males, and for females we see the impact of general education is actually 349, which is quite different from 409 that we had for the regression with both males and females. Or if you see experience square, it is also less, it is 95.8, or experience square, it is minus of 1.02, right? So there are actually the coefficients are not same. If you run a subsample regression, the coefficients are not same, which we actually claimed in our regression with the dummy variable, okay? So that is an assumption we have to remember we are making when we are running a regression equation with a dummy variable. So it is as if the moment you have just the intercept dummy, it is as if our regression equation for the two categories are going to be same only except the difference in the intercept term, right? So that is a sort of a big assumption we have made when we are running our dummy variable regression with the intercept dummy, okay? So how to really address that, we are going to see in the next lecture how to really address that. But before that, we will from the binary category of dummy, in the next lecture we are going to talk about a dummy variable with multiple categories and how to actually incorporate those multiple categories. But of course, we need to explain the other type of dummy variable apart from intercept dummy, which is only explaining the intercept term but not the slope term. So we'll see this in the next couple of lectures. Thank you.